Okay, we're going to start looking at some elementary trig equations here, like we see right here. Okay, these things like sine x equals 1, sine x equals 0, sine x equals 1/2. And yeah, the way we're going to actually look at them best is to call upon their graph. So I'm going back to the Desmos here, and I'm going to say, well, where's the sine of x? Here's my graph of my cosine of x. Let's look at the graph of the sine x. Here's my graph of the sine x. Okay, so here's my graph of the sine x. I said, where is it equal to 1? If I drew a horizontal line at y equals 1, then I say, well, I hit here, so I say, well, can that equal solution? Absolutely. X equals pi over 2 is a solution, but it is not the only solution. Sorry about that. Okay, I'm going to get my pen up here and working. All right, so get my pen. So x equals pi over 2 is a solution, but as I said, it is not the only solution. So what do I mean by that? Well, okay, if we zoom out, or zoom in rather, on our sine graph, okay, we say that it can equal 1 here, everywhere down the line. Okay, it hits at the sine graph hits the value at 1 at every cycle. So the next time it's going to hit is at 2 pi down the line, which is 1 wavelength, and every multiple wavelength down the line. So I'm going to say plus 2 pi k, which will cover all the values at which the sine graph, okay, the sine graph is going to equal, okay, I'll put my sine graph up here, is going to equal 1. So there's my sine graph. Here's the value of 1. This is not really cooperating. I'm sorry. Okay. Here's my 1. Here's the first strike at pi over 2. Next time is going to be 2 pi down the line, which would be right here. It's going to strike another 2 pi down the line, which is going to strike 2 pi back here. So this covers all my solutions. Now, if I were to say, well, where's the sine equaling 0? Okay. Where's the sine equaling 0? Here's my graph, okay? Sine equals 0, 0, pi, 2 pi, 3 pi, 4 pi, at all values of pi. So the answer there would be x equals, okay, pi k. Pi k. Remember, k is just an integer, so it's 0, which when k is 0. When k is equals 1 is 1 pi, and so on and so forth. Now, let's look at the graph of sine and see where does it equal 1/2. Okay, where does the sine graph equaling 1/2? Okay, pull up our sine graph here again. Okay, zoom in. All right, we can say here's a value of 1/2 right here. Okay, and we can see it hits at 2 points. It hits at 2 points. First strike is at pi over 6. But then the sine is positive again and takes on a half value at 5 pi over 6. So basically, there's 2 sets of answers for this guy. So it's at x equals pi over 6 plus the 2 pi k values on top of that, and x equals the 5 pi over 6 plus all subsequent hits down the line. So at pi at sine of x equaling 1/2, we have 2 strikes per cycle. Now let's talk about our cosine graph. Okay, where does the cosine assume the value of negative root 3 over 2? So let's pull up our cosine graph. Okay, here's our cosine graph. We'll take away our sine graph. So here's the cosine going negative. Okay, now these are familiar values to you. Okay, cosine is negative in the lower two, in the second and the third quadrant, right? So the second quadrant, cosine takes on a root 3 over 2 value, root 3 over 2 at the pi over 6 value, right? At the pi over 6, but it's in the second quadrant, so that's 5 pi over 6, 5 pi over 6. But all periods down the line plus 2 pi k, and in the third quadrant at 7 pi over 6 plus all 2 pi k values down the line. Okay, and that's my solutions to that guy. Now Now the question is, what about the tangent? Well, let's go and talk about the tangent, because the tangent's a little bit different than sines and cosines, so we're going to take a look at that. Okay, let's just pull this up full view. Okay, but now to get the tangent graph, it's actually the sine over the cosine. So the sine over the cosine, we have to be concerned with where does the cosine strike 0. The cosine, or where does the cosine strike 0? At pi over 2. Okay, so if we're dividing by the cosine, wherever we divide by 0, we're getting it undefined. So the graph of the tangent is going to come up, and here it is. Okay, here's our value of pi over 2. Okay, in which we see there's an asymptote. Okay, all right, there's another asymptote where the cosine hits 0 again, which is 3 pi over 2. Okay, and if you can see, in between two asymptotes, we have the entire tangent graph. We have the entire tangent graph, which means, okay, that the tangent graph, its period is only half the period of the sine or cosine. So if we look back here, here's a value of negative pi over 2. Negative pi over 2 is our value over here. Okay, and between negative pi over 2 and positive pi over 2, we get one entire graph of the tangent. So the tangent spans pi units, not 2 pi units per cycle. Okay, the other unique feature about the tangent, and let's just look at the tangent here, okay, is that, okay, the range of the tangent is from negative to positive infinity. And so any horizontal line is only going to strike the tangent at one point. Unlike the sine and cosine graphs, okay, the sine and cosine graph, okay, when I'm after the sine of x equaling any value between -1 and +1, it's going to strike twice per cycle. Okay, contrary to that, the cosine, the tangent for any value where the tangent is going to be equal is only going to strike once per cycle. Okay, so if we come back to our problems that were here, okay, and I say, where's the tan of x equaling 1? Okay, well, we know that 1 for the tangent, that the tangent assumes 1 at a pi over 4 value. Okay, but then it's going to assume it another wavelength down, which is again going to be just pi k. So the tangent is going to strike once per cycle, and its period is, okay, pi, not 2 pi k. So there you have your introduction to some elementary trig functions. We'll take a look at a couple in the next worksheet on a little bit more sophisticated ones, like your worksheet problem. So okay, so we'll get to that in the next video. Okay, so for now, elementary, and what you're going to find is that all your more sophisticated trig functions are going to come down to things of this sort. Okay, so that's why you need to know this stuff. Okay, and all that would be recalled by going through your table again, maybe even building your table, your sine, cosine, tangent table at those critical angle values of what the pi over 6, the pi over 4, and the pi over 3. So you want to remember those. Okay, it's just what, 1/2 root 2 over 2, root 3 over 2. You're going to want to recall those: root 3 over 2, root 2 over 2, and 1/2, and then of course root 3 over 3, 1, and root 3. So your sine, cosine, tangent. Before we said that the sine of pi over 6 is 1/2. Now we're saying the sine of what is 1/2, okay? Or the cosine of what is root 2 over 2, or root 3 over 2. Okay, so you got to remember those. Okay, and we'll take a look at some more sophisticated problems. And again, this stuff is also mentioned in the PowerPoint slide. So there you have it.